Okay, so I usually wouldn't do this kind of video here because I want you to try this kind of stuff for yourself, but there was a mention of some steps being missing in some other solutions people looked at, so um, I don't want this to be another source of frustration, but that was just maybe fill in some gaps, and maybe you can do this after you had to go at it yourself. So, we said the problem reduces to this routine differentiation kind of problem. And so we need to differentiate tan theta, okay? And I mean, a lot of the people going into the exam will know that the answer is sec squared theta, okay? And one on cos theta, which is a sec theta, and I think it should be sec theta tan theta. Okay, so I think it's not unreasonable for people to know this, but it is also not unreasonable to be able to figure what these things are based on sort of the more standard results. So we know that, for example, tan theta can be written as sine theta on cos theta. Okay, and then so we know that the derivative of sine is cosine, the derivative of cosine is sine minus sine. So we can then use the quotient rule to get the derivative of this fraction. Okay, so the quotient rule, we have differentiate the top times the bottom minus the derivative of the bottom times the top. So there'll be two minus signs. And then over the bottom squared. Okay, so can you see that that plus that is equal to 1? And therefore 1 over cosine squared is sec squared by definition. Sec is 1 over cosine, so that's how it ends up there. And you can use a similar thing here. Or you could try to use a chain rule with 1 over as one of the functions. So if it was just 1 over x, the derivative with respect to x would be negative 1 on x squared. It would be negative 1 on cosine squared theta. But then you got to multiply it by the derivative of this when it's not just x, or when it's not just theta. So then you're going to multiply by minus sine theta. So minus makes it a plus. Okay, and can you see that sine theta over cosine theta is tan theta? And then this extra 1 over cosine theta gives you the sec theta. Okay, so knowing that those are the derivatives, set that equal to 0. So we want to set 0 equals 50 over 3 times sec squared theta minus 125 over 2 times sec theta tan theta. Okay, so one of the questions that comes about is sec theta equals 0? Well, so 1 on cosine theta for theta being acute will not be equal to 0. So we can get rid of the sec theta. Okay, then we have we have basically 0 equals 50 over 3 sec theta minus 125 over 2 tan theta. Yeah, we could get rid of the sec, which is by multiplying by cosine, for example, and cosine, because cosine is not 0 in this domain for theta. So multiply but that will give you sine theta. And then we'll have basically sine theta equals this over this. So sine theta equals 50 over 3 divided by, times by 2, 125. Okay, I don't usually write the equal signs on the right, but just for convenience here, so I usually write the equal signs below and in line. So let's simplify this fraction. So 50 and 125 becomes 2 over 3 times 2 over 5. And so this is 4 over 15. Okay, and of course, if theta is acute, there's only one angle for which angle theta for which sine of that is 4 over 15. And that should be our maximum. Okay. You might want to test the maximum. For example, you might want to say that this expression is this makes this 0, and if it's bigger, it'll make this positive, and if it's smaller, it'll make it negative. So if it's smaller, it'll make it positive. If it's bigger, it'll make it negative, and then you get this kind of maximum shape. Okay, so hopefully you can continue the rest yourself. If you have any questions, let me know in the comments or send me a message.